Ideal gas and real gas. Ideal gas is that gas which obeys the ideal gas equation, that is PV is equal to nRT under all conditions of temperature and pressure. Whatever the temperature, whatever the pressure, under all conditions, ideal gas must obey this ideal gas equation, that is PV is equal to nRT. But practically, no gas is ideal gas. Next is the real gas. Real gas which obeys gas laws only under certain conditions. What are that conditions? Low pressure. At low pressure and high temperature, real gases obeys the ideal gas equation, and all gases are real gases, whether it is hydrogen, oxygen, nitrogen, carbon dioxide, all gases are real gases. Compressibility factor. Compressibility factor is what? It is that factor which tells the extent by which a real gas deviates from the ideal behavior and is represented by Z. This is the compressibility factor. To what extent a real gas deviates from the ideal behavior, which is expressed by the compressibility factor Z. Z is equal to PV upon nRT. As you can see in this graph, this straight line parallel to the pressure axis shows the ideal gas behavior. And some of the gases like nitrogen, hydrogen, helium, they show upward curve, upward line, and some of the gases show curved lines and below the ideal gas line. This is the graph between compressibility factor and pressure. If Z is equal to 1, then the gas shows ideal behavior and it obeys the ideal gas equation. And this Z is equal to 1 graph is parallel to the pressure axis. If Z is less than 1, if compressibility factor is less than 1, it means it shows negative deviation. That gas shows negative deviation. As in case of CH4, CO2, etc., they all show negative deviation. It means these gases are more compressible. If Z is greater than 1, like in nitrogen, hydrogen, helium, they show positive deviation. It means a gas is difficult to compress. It is difficult to compress. Those gases show the positive deviation, and the value of compressibility factor for that gases is greater than 1. Means Z is greater than 1. Z is less than 1 when the gas shows negative deviation and is more compressible. At Z is equal to 1, it shows the ideal gas behavior. Next is significance of the compressibility factor. Here in equation number 1, Z is represented for real gases. That is, Z is equal to PV real, volume of the real gases, divided by nRT, where P is the pressure, N is the number of moles of the gas, R is the gas constant, and T is the temperature. And for V ideal, if we rearrange this, which is equal to nRT upon P. Here Z is equal to 1. And we can calculate the volume of ideal gas from this equation. And substituting the second equation in first equation, we get Z is equal to V real upon V ideal. It means compressibility factor is the ratio of actual volume of the gas, means calculated value from the experiments, to the theoretical value of the gas, that is V ideal. Means compressibility factor shows a relation between calculated value and the theoretical value of the volume of gas. Cause of deviation. Why real gases deviates from the ideal gas behavior? This is due to the two assumptions which were made by the kinetic gas theory of gases. First one is the volume occupied by the gas molecules. Gas molecules here is considered as the point charges, is negligibly small as compared to the total volume of the gas occupied. This is the total volume of the gas, and the volume of one gas molecule is negligible. Total volume of the gas is greater than, which is very greater than the volume of the molecule of gas. Next factor is the force of attraction between the gas molecules are negligible. It is considered that the gas molecules are farthest from each other and there is no force of attraction between the gas molecules, and it is considered as negligible. Due to these two assumptions, real gases show deviation from the ideal behavior. If the pressure is high and temperature is low, these two conditions are valid under low pressure and high temperature. Low pressure and high temperature. But if we reverse the conditions, means pressure is high and temperature is kept low, the gas molecules come closer to each other. Hence, under these conditions, the forces of attraction or repulsion between the gas molecules may not be negligible. It means they matters. Second, the volume occupied by the gas molecules may be so small that the volume occupied by the gas molecules may not be negligible in comparison to the total volume of the gas. It means it also plays a role. The volume of the gas molecules is not considered as negligible in comparison to the total volume of the gas under high pressure and low temperature. To correct the ideal gas equation, van der Waal introduced some new factors. First one is the correction factor for attractive forces between the molecules, which is represented by A. This is the magnitude of forces of attraction. Forces of attraction. And B, which is the volume of gas molecules, which is not considered as negligible. These two factors A and B are added in the ideal gas equation, and the final equation is called the van der Waals equation, which is equal to P plus n square A upon V square into V minus NB is equal to nRT. This is for n moles of the gas. P is the pressure, V is the volume, and A and B are the van der Waals constants. A represents the magnitude of forces of attraction and B represents the volume of gas molecules. R is the gas constant and T is the temperature. For 1 mole of gas, N is equal to 1, and the equation becomes P plus A by V square into V minus B is equal to RT. This is the van der Waals equation.